Subsets. A subset is a set of elements that is a part of a larger set. For example, a set A could be the set of natural numbers from 1 to 10. So in roster or tabular form, it's written as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 within the braces. And set B is a set of natural prime numbers less than 10. So within the braces, those would be 2, 3, 5, and 7. All of the elements in B are a part of A. So B is a subset of A. And here's how it would look in a Venn diagram. Here's another example. Set C is the set of natural odd numbers less than 10, so it contains 1, 3, 5, 7, and 9. And set B is still the set of natural prime numbers less than 10, which consists of 2, 3, 5, and 7. Not all of the elements in B are a part of C. For example, 2 is not an element of C. So therefore, B is not a subset of C. Here's another example. Set D is going to be all positive multiples of 6, and set E will be all positive multiples of 3. So is D a subset of E? Explain. And then is E a subset of D? Explain. Well, let's actually investigate this. So first let's write out each of these sets in tabular form. So first let's start with D. D is going to be all positive multiples of 6. So that's going to be 6, 12, 18, 24, 30, and it keeps going. Okay, and now set E are all the positive multiples of 3. So we have 3, 6, 9, 12, 15, 18, and it keeps going. So if we compare the elements of D and E, we can see that, well, D, all of those values, and if I kept going, I would get 24 and 30, they're all within E. So yes, D is a subset of E because all of its elements or all of the elements of D are also in set E. Now let's look at the second question. Is E a subset of D? Explain. Well, 3 is not in set D. 6 is. 9 is not also in set D. 12 is in set D. So you can see set E, there are more elements in E than there are in set D. So therefore the answer to this question is no. Not every element from E appears in set D. And here are the solutions to these two example problems, and they do match the solutions that we found. Since all the elements in D are also elements of E, D is a subset of E. However, not all the elements in E are also found in D. So therefore, E is not a subset of D. Now the properties of subsets bring up a very interesting question. Can a set be a subset of itself? Let's think for a minute about the definition of subsets. If we have a set T, would every single element of this set T be in T? Well, yes, of course it would. It would have to be. So this allows us to say that set T is a subset of T, or that T is a subset of itself. But is this proper to say? Take a moment and pause this video and think about it, and when you're done, unpause it. It doesn't really seem proper to say that a set is a subset of itself. This leads us to what are known as proper subsets. A proper subset is a set of elements that is a part of a larger set, and at least one extra element exists in the larger set. So in our example, set A, the set of natural numbers from 1 to 10, which written in roster or tabular form is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And set B is the set of natural prime numbers less than 10, or 2, 3, 5, and 7. All of the elements in B are a part of A, and A contains more elements. Therefore, B is a proper subset of A. Now let's try an example with proper subsets. Let's let D be all the positive multiples of 6, and set F be the set 6, 12, 18, 24, and 30. So then, is D a proper subset of F? Explain. So first, let's write out what set D is in tabular form to make it easier for us to analyze it. So set D are all the positive multiples of 6. So we have 6, 12, 18, 24, 30, and so on. And we have set F as 6, 12, 18, 24, and 30. So is D, this one that keeps going, a proper subset of F? The answer here is no, because D keeps going on forever and ever. D is not, first of all, it's not a subset of F, so it can't be a proper subset of F either, because not every element from D appears in F. Now let's reverse this. Is F a proper subset of D? Explain. Well, F starts with 6, 12, 18, 24, and stops at 30. D has all of those same elements, and then it continues, and it'll have 36, 42, 48, and so on. So therefore, yes, F is a proper subset of D because every element from F appears in D, and set D contains more elements. And here are the solutions to these two example problems, and they do match the solutions that we found.